Hello everyone. In this video, we're going to go over some examples involving continuous distributions. In particular, we'll look at three examples. The first is a fairly routine example where we find the marginal with respect to y and use that to find the conditional distribution of x given y. We follow that up with a similar practice problem, and then look at an extension of the practice problem. So let's start off. Suppose we have a joint density f of xy is 3 over 80 times x squared plus y. Defined over this rectangle, we find the marginal PDF and then the conditional. So to find the marginal with respect to y, we need to integrate out x. So we set up the integral, we go 0 to 2, because we're integrating with respect to x. Here's the joint density dx. So when we integrate this term here, you see we'll have 3 over 80 times x cubed over 3. The 3's cancel. We get x cubed over 80. And then here we have the 3 over 80 xy. Evaluated from 0 to 2. So when I substitute in 2, we get 2 cubed is 8. 8 over 80 simplifies to 1/10. And this would be, well, 3 times 2 over y, but 2 goes into 80. So we're left with 40 in the denominator, and we have 3y in the numerator. So this would be our marginal PDF. And remember, y varies from 0 to 4. Now to get the conditional, we simply take the joint density divided by the marginal density. Okay, so we might start out with something like this. We should try to simplify this. So what I might do here is multiply by 80 over 80 here, do some canceling and a little bit of algebra. So after simplifying, you see we end up with 3 times x squared plus y over 2 times 4 plus 3y. Now it's much easier if you simplify here, especially if you have some follow-up probabilities to calculate. Your integral would be much easier if you have this simplified expression. In example 2, let's let x and y again be a pair of random variables with a joint density, 1/9 times 3 minus x times 2 minus y, for x between 0 and 3, y between 0 and 2. So our region is once again a rectangle. And we want to carry out some similar calculations, find the marginal with respect to y, and then the conditional. So this is a good problem for you to try. I suggest you stop the video and try to work out the answer. Okay, so here is the solution. For the marginal with respect to y, we're going to integrate with respect to x. So I could take out the term involving y. So I take 2 minus y outside of the integral. And then we're looking at the integral from 0 to 3, 3 minus x over 9 dx. So this gives us my 2 minus y term. 3/9, integrating that with respect to x, we get 3/9 x. And then here I have minus x over 9. When we integrate, we get x squared over 9 times 2. I get x squared over 18. Evaluated from x equals 0 to 3. So you could see when x is 3, we get 3 times 3 over 9, so I get 1. And this will give me 3 squared 9 over 18, which is a half. And then when x is 0, I just get 0. So this term is just 1 minus a half, which is a half. You could see our final answer here is 2 minus y over 2. Next, we want to put together the conditional distribution of x given y. So I start with the joint density divided by the marginal. It's easy to see here that the 2 minus y's will cancel out, and then bring this 2 up. So I get 2/9 times 3 minus x. Did you get that answer? I bet you did. Now, let's take a look at a follow-up example. So suppose I have the same joint PDF defined over this rectangle, x between 0 and 3, y between 0 and 2. And let's say we want some more specific probabilities. So the first one, the probability x less than or equal to 2 given y is 3/2. And in the second, we flip it. Probability y is greater than or equal to 1 given x is 5/4. So we can go back to our joint, well, not the joint distribution, we go back to this conditional distribution because we have a conditional probability to find. And here I have x given y is this function. Notice that this function does not contain any y terms. Okay, so the distribution of x given y will be equal to this distribution x given y equals 3/2. We could find this probability by evaluating the integral. So I have 2/9. Evaluate from 0 to 2, 3 minus x dx. And it's pretty easy to see that this will give us 8/9. Now for the second probability, okay, we want the probability y is greater than or equal to 1 given x is 5/4. Well, you would have to try to find the conditional now of y given x, which means we need the marginal, want the marginal distribution with respect to x. If you work this out, I didn't work out all the details here, but if you work this out, you should see that you get the same function as the conditional of x given y, which we have right here. Okay. So what does it mean when these two functions are equal to each other? Well, it means that y doesn't have any effect, or in other words, x and y are independent. So that simplifies our probability. The probability y is greater than or equal to 1 given x is 5/4. Well, this isn't going to have any effect at all, so it's equal to the probability y is greater than or equal to 1. So we go back to the marginal PDF, find the integral from 1 to 2. Remember, y is bounded on top by 2, so we integrate from 1 to 2. This is the marginal PDF with respect to y, 2 minus y over 2. So this is an easy integral to work out, and you should see that this will give us 1/4. So this concludes the video. I hope you found it useful.